Good day everyone. Our next topic is binary codes. In coding, when numbers, letters, or words are represented by a specific group of symbols, it is said that the number, letter, or word is being encoded. The group of symbols is called as a code. The digital data is represented, stored, and transmitted as group of binary bits. So this group is called as binary code. So those groups that are represented with digital data is known as binary codes. The binary code is represented by the number as well as alphanumeric letter. So from 0 to 100 to 1000 to millions, and alphanumeric letters are represented by binary codes. So there are different categories for your binary codes, or there are different classification of your binary codes. First is you have your weighted codes or non-weighted codes. Second is binary coded decimal code. Third is alphanumeric codes. Fourth is the error detecting codes or error correcting codes. We will start with binary coded decimal code. In binary system, most natural system for computer that are being used by most people are decimal system. So those numbers from 0, 1, 2, 3, 4, 5, and so on are known as decimal system. So those decimal system is mostly used by people nowadays. So one way to resolve this difference is you have to convert your decimal numbers to binary and then convert your binary results back to decimal. So this method requires that we store decimal numbers in computer so that they can be converted to binary. So since your computer can only accept binary values like 0 and 1, so your decimal digits must be represented by means of codes that contains ones and zeros. So ang tanan ninyong numbers and alphanumeric letters will be represented by codes. So in this code, each decimal digit is represented by 4-bit binary number. So again, for BCD code or your binary coded decimal code, it is represented by a 4-bit binary number. So when you say 4-bit, mahugray siyag upat from 0, 0, 0, 0, 1, 1, 1, 1, 1, 0, 1, 1. So 4 bits, yeah. Your BCD is a way to express each of the decimal digits with a binary code. So your BCD code is used to express your decimal digits. So example, your 0 will be expressed as 0, 0, 0, 0, while your 11 will be expressed as this one, 1, 0, 1, 1. And then your 15 will be expressed as the 4 ones. So again, in BCD, there should be 4-bit binary numbers. So in the BCD, there will be 4 bits which can represent the 16 numbers from 0 to 1111. But in BCD code, there are only 10 numbers that will be represented. You have your 0 to 9, okay, 10 man. it will be 0 to your 2 raised to the power of n minus 1. So if your n is 10, then it will be deducted by 1, so mahog siya 9. So again, your BCD code, only first 10 are used. You start with 0, you end up with 9. So the remaining 6 code combination, your 10 to 16 code combination, or your 1010 and 1111, serve as your 15 combination, is invalid in BCD. So again, your BCD code can only accept 0 to 9 or 0000 1001. I-accept siya. So only accept 0 to 9. And your 10 to 15 will be invalid. 10 to 15 will be invalid. So, dili siya i-accept sa imong BCD code. So, these are the list of your binary coded decimal. Again, the numbers that can be accepted to your binary coded decimal is from 0 to 9. Siya 9. And then, it can be represented in digits. We use BCD as 4 digits. So, 4 zeros and 10001 as 9. So, for BCD, you will have 4-bit code digit for 1 decimal digit. So, a number of key decimal digit will require 4 key bits in BCD. So, if you have 0 number of decimal digits, so there should be 4 0 bits in BCD. If you have your 1, there should be 3 0 and 1. That will serve as your 1. Your 2 will serve as this one. 3, 4, 5, 6, 7, 8, and 9. So these are the list of binary coded decimal. So this is an example of binary coded decimal. You have your 396 decimal number, and can be represented in BCD with 12 bits. Why 12 bits? As you can see, there are 3 number of digits, and each BCD there should be 4 bits, diba? 4 bits man siya. So, i-times mo 4, so there should be 12 bits in each decimal value 396. So, how to convert your decimal into BCD? So, again, in converting BCD, you have to convert each digit into 4 bits. So, kani siyang tulo, i-convert nimo into 4 bits. The equivalent for 3 is this one. Nga dayon, space dayon. So, that means kani siyang 4 coded for 3. So, this will serve as your 9 and then your 6. So, again, your BCD value for 396 is 0011, 1001 for 9, and 6 is 0110. So, this is an example of your binary coded decimal. So, a decimal number in BCD is same as equivalent binary number, only when the number is between 0 and 9. So, whatever the decimal number in BCD will be equivalent to the binary number, only when the number is between 0 and 9. So, di siya malapas og 10 and to 15. So because they are invalid for BCD. So BCD number greater than 10 looks different from its equivalent binary number. So even though it consists of zeros and ones. So again, your 10 binary number and 15 are not used and have no meaning in BCD. So they are invalid in BCD. Your 10 and 15. So this is another example of binary coded decimal. So another decimal value is 185. So you have to get the corresponding value in BCD. You have to get the corresponding value in BCD and in binary. So how to get your binary, diba? You will be using exponential katong form or by dividing by 2. So it's up to you kung sa inyong gamiton. You will be using exponential form table or the divided by 2. So again, for 185, so it is coded as 1. This will serve as your 1 and your 8. And the other one is 5. Kani siya. So to represent 185 in BCD, it should be this one. 0001, then space 1000. That will serve as your 8. And then your 5, which is 0101. This is for your BCD. While for binary, so it will be represented with this one. You can use the decimal katong divided by 2, or you can use the exponential table, or you can even use your calculator. So always remember the important for BCD. Your BCD numbers are decimal numbers and not binary numbers. So again, whatever the value of your decimal number, so it will also be the value of your BCD. So if ever you have your 185, so 185 sad any mong value, but it will be coded. So we'll start with 1, a decimal number, gi-code siya into 1 sad binary. And then your 8 decimal number will be coded by 8 binary representation. Then 5, which will be coded as 5 representation. Unlike for binary numbers, nga gi-count gyud siya. This one. So another difference between BCD and decimal is that your decimal will be written with symbols 0 to 9. And your BCD numbers are same lang kapag siya, 0 to 9, but it will be represented with 4 bits of zeros and ones. So decimal value is exactly the same with your binary code, but the only difference is ang representation sa imong decimal is by using 0 to 9. While for BCD numbers, it will be 0 of the 4 bits of zeros, or the 4 bits which is represented with zeros and 1. Next. So this is another example for binary coded decimal. So your first example is 10. 10. Your 10 will be represented with BCD as this one. So this will serve as your 1 and then your 0. So mahog siya 10. So again, your decimal number is just equal to your BCD. The only difference is your decimal number will be represented with 0 to 9, and this one is represented with 0 and 1s in 4 bits. So same ra silang value 10. The next is the binary value for your 10, which is 1010. Binary number. Another example, you have your 15. So your 15 is represented with binary coded decimal, which is your 1. Can you see? Yeah? And then your 5 will be this one. And then it will be represented in binary as 4 ones. You have your 8 plus 4, 12 plus 2, 14 plus 1, 15. Kani sa siya 1 is iya kay 0. Kani sa siya 1 is iya 1. And then this one is 5. So, diba 8 man eh. Diba 8? Your 8 is off man. So, wala na siya. Di siya makount. Next is 4, which is on. 4 plus 1, 5. So, manang 15 siya. Another example is your 237. The binary coded decimal for your 237 is 2. You have your 2, 3, and 7. Then in binary code, so the equivalent for your 237 will be this one. So again, to get that value, you will be using the exponential table or the division of 2. Next example is 760. That will be the answer for 760. So that will serve as your activity. So in this activity, I want you to or you can pause for a while and then have to check the value for this one. I will check ha. So for 7 in BCD, 5 minutes lang, and then we will check if your answer is just the same with my answer. We will start with your 760 with BCD. So in BCD, the representation for your 7 is 0, 1, 1, 1. So this will serve as your 7. Your 6 is 0, 1, 1, 1, 0. 6 na siya. For 0 is 0, 0, 0, 0. So this will serve as your BCD. How about for binary? So, for binary, on ang 512. So your 512 will be added by 256. So if you're going to add 256 and 512, sumula pa siya. Mahog siya. 512 and 256. Mahog siya 260 na kapin. So off ang 256. How about 128? 512 plus 128 is equals to 10, 30, 630. Pwede pa. On. What else? Next for 128 is 64. 64. 64 will be on. 64 plus 128 is equals to 12. 192. 192 plus 512 is equals to 4, 10, 704. So, okay pa siya, 704. 704. Another one is 32. 704 plus 32. 32. Mahog siya, 7, 3, 6. 3, 6. Pwede lang 32. Next is 736 with 16. 16. Mahog siya og 7, 4, 2. So, okay ra sa dan 16. On ra sa dan 16. Next for 16 is 742. 742 will be added with 8. 8. So, mahog siya 752 din siya. 752. So, serve as 752. Okay, 12. Then 3. Yeah. Be added by 8 to make it 760. So, on siyang 8. The rest is of 4, 2, and 1. See the value for your 2. The value for your 760 is 1, 0, 1, 1, 1, 1. 1, 2, 2, 5, 6, 64, 32, 32, 16, 8, 0, 0, 0. So this will serve as your 760 in binary numbers. Kindly check lang if my answer is just the same with you. So this is how to get your BCD code and your binary. So what if you're going to add 2 decimal digits in BCD? So how to add your BCD? So in adding 2 decimal digits in BCD, since each digit does not exceed to 9, diba, ang mga digits for BCD will not exceed to 9, so the sum cannot be greater than 9 plus 9 plus 1 is equals to 19. Because it will serve as a carry, ang 1 nimo, previous carry. So 9 plus 9, 18 plus 1 is equals to 19. So with the 1 being a previous carry, kay it should not exceed to 9 man. So your 1 will serve as your previous carry. So adding 2 binary numbers. How about if you're going to add 2 binary numbers? So the binary sum will produce a result in the range of 0 to 19. So in BCD, your 0 to 19, where your 1, kani siyang 1, kani siya na 1, will serve as your carry, and the next 4, kani siya nga 1, will serve as your carry, and the next 4 bits being the BCD sum. So that is for the BCD addition. So again, if your answer will exceed 2 to 9, kaya di mo siya pwede mo exceed to 9. So, the 1 will be your carry, and the next 4 bits will be your BCD sum. So, let's have an example for you too. Or, let's have a rule or for you to understand more about BCD sum. The rule to understand more about BCD sum. So when binary sum is less than or equal to 9, so this will serve as your 9. 9 man ni siya. Hibaw mo nga nung 9 ni siya. Because if this one was kani siya, mahug ni siya 9. Why 9? Because this one will serve as your 8 plus 1 mo ng 9 siya. So again, the representation for your 9 in binary number is 1001. So if your BCD is less than, BCD sum or binary sum is less than or equal to 1, less than siya or equal to 9, so again, your BCD digit is correct. Correct siya. So again, if your sum is less than or equal to 9, your BCD digit is correct. So when your binary sum is greater than or equal to 10, so your BCD digit is invalid. Invalid siya kay ni-exceed naman siya 9. Ang 10, di ba? Ang 10, if your sum is greater than or equals to your 10, ay mong BCD digit is invalid. So if you have an invalid sum, so the solution for that one is you have to add 6 to the binary sum to convert it to correct digit. So kung invalid gani mong answer, you have to correct your sum to make it valid. So you have to produce a carry as required. So again, what is the solution if your BCD digit is invalid? You have to add 6 to your binary sum to convert it to correct digit, and you can produce a carry as required. So this is an example of BCD addition. So for this one, for the first example kani, this one, as you can see, this one, as you can see, your sum is 9, which is equal to 9 ra. So your sum is just equal to 9. So this will serve as valid. So if you're going to convert 4 into binary, kanila siya. Or BCD, kana siya. You have your 4 plus 5 is just equal to 9, which is valid. Valid di siya, okay ni siya. Next example. As you can see, your next example is 4 added by 8. So your sum is 12. So what's the rule for this sum? If your sum is greater than or equal to 10, so the rule is your sum is invalid. So invalid and siya. So what should you do if your BCD sum is invalid? Diba in the rule, you have to add 6. Mag-add kag 6. So the rule is you have to add 6 to make your sum valid, and you have to produce a carry. So that's why kani siya invalid naman ni siya. Then gi-added niya 6. Kani siya. Gi-added niya 6. The result is kani siya. So there is a carry. So this will serve as your carry, and this will serve as your BCD sum. So if you're going to check, the BCD code for 12 is 1 and the 0010 for 2. Another example. So again, this is invalid din siya ha. No, so all you have to do is you have to add 6 to obtain the correct BCD sum and a carry. So nahog din siya correct BCD sum with carry. The next example. Your example is 8 plus 9. So if you're going to check your BCD sum, kani siya is invalid. So invalid siya. So all you have to do, ngano na-invalid man na siya, because your sum is greater than or equal to 10. Greater than 10. Diba ang 17 is greater than 10. So that will serve as an invalid code. Invalid code. So all you have to do is to add 6 to make it correct. So mao na siyang 6 nga gi-add. So your BCD sum will be this one with the carry. Yan siya, mahog ni siya carry. So the correct BCD sum is this one, and this will serve as your carry. So okay ra, nasabtan ra. Another example. As you can see in your first example, the sum is equal to 9. So that's why you have the result of the correct BCD sum. So in second example, the binary sum produces an invalid BCD digit. So the addition of 6 produces a BCD sum of 0, 0, 1, 0 and a carry 1. On third example, the binary sum produces carry. So kani siya, wala siyang produce og carry, pero invalid lang kapon siya. So for the third example, na-produce siya carry kanang 1. Kaning 1. So produce carry. So this occur that your sum is greater than or equal to 16. So all you have to do is to add 6 lang to make it a correct BCD sum with carry. So this will serve as your correct BCD sum niya, ang carry niya nga 1. So next example. So this example is addition of 2 integers assigned BCD numbers. So again, the procedure, you have to follow the procedure below. So you have your BCD, and then BCD numbers added, and then you have your binary sum, then you have to add 6 if your binary sum is invalid. And this will serve as your BCD sum. So this example is adding your 184 and 576. All you have to do is to get first your BCD value. So the BCD value for 184 is kanisha. This will serve as your 1. This will serve as your 8 and 4. The next part is the 576. So this will serve as your 5, 7, and then 6. Then after that, you have to add all the numbers, assigned BCD numbers. So again, in adding binary numbers, don't forget, if your 0 is added by 0 is just equal to 0. If your 0 is added by 1 is 1. And if your 1 is added by 1 is 0. Carry 1. Here, bring down 1. you have your 1, 1, 1. So it will be 1, carry 1, bring down 1. So don't forget the addition of binary numbers. And in this example, we will start to add the 0 and 0. So the result will be 0. Siya. And next, 0 and 1, 1. 1 and 1, 0, carry 1. Now, carry 1, then 1. So, if you're going to check ano niyang result, so this is an invalid number. Diba? Mahog siya invalid number. Why? Because this will serve as 10. So, in BCD, if your binary sum is greater than or equal to your 10, so, mahog siyang invalid. So, all you have to do is to add 6. So, mauna ni ang gamit ni 6 diri. So, gi-addan siya 6 to make it valid. So, if you're going to add 6, so, inig-add na ana niya, will start with 0. Yan siya, mahog siya 0. Then, carry 1, 0, carry 1. And next is 1 plus 0, 1. 1 plus 1, 0. And carry 1. 1 plus 1, 0. So, after na, kani siya na 0, na siya carry. So, mauning kani ang gibutang diri. So, next part. So, you have to add your 8 and 7. Kani siya 8 og 7. Since na naman kay carry diri sa taas, you have to add sad na siya. I-appel siya add. So, if you're going to add 1 plus 0 is 1 plus 1 is 0. Ano siya? 0. So, you have to carry 1. Na siya carrying a 1. Yan, 1 plus 0, 0. Plus 1, 0. Carry 1. Carry 1. So, 1 plus 1, 0. Nagapon, carry 1. Nagapon. 1 plus 1, 0. Carry 1. So, 1 plus 1, 0. Carry 1. So, after nag-carry, you can bring down 1 na. So, mga na siyang nahog siya. 1, 0, 0, 0, 1. So, the 1 for that one is the carry. And that will serve as 16. Diba? The value of 16. Since it is invalid, so you will have to add 6. So, after nag-add og 6, mahimo na siyang 6. Mahimo na siyang 0 plus 0, 0, 0 plus 1, 1. 0 plus 1, 1. 0 plus 0 is 0, carry 1. Yeah. Carry 1. 0 plus 0, 0. Yan namning 1. So, kani siya, mahog ni siya carry na. Kani siya mahog na ni carry. So, you have to put your carry sa taas. So, if you're going to add the 3, 1, it will result as 1. Nya, dayon, remainder 1. Bring down 1, carry 1. If you're going to add 1 plus 0, that's 0, it will serve as 1. Yeah, 0 plus 1 is 1. 0 plus 0 is 0. So, for this one, so dili mo siya invalid. Kay 7 is not an invalid binary code man. Ayan siya 7. So, no need to add na 6. Wala na ni siya during 6. if you're going to add na sa diri, this will serve as your 0. Di ba? 0 naman to. Kani serve as this one. Kani serve as 7. So, if you're going to check kung kana ba imuhang total is just equal to your kanimong total is just equal to your 760, so kani siya will serve as your 7. If you can see, this one will serve as your 7. Kani siya will serve as your 6, and will serve as 0. So this is your answer for your BCD addition. Another example. Wala na example. So how about if you're going to add BCD code using negative numbers? Negative numbers by using negative numbers. So the representation of signed decimal numbers in BCD is same with signed numbers in binary. So we can use either signed magnitude and signed complement system. So the sign of decimal number is usually represented with 4 bits to confirm the 4-bit of the decimal digits. So, diba, from your decimal digits or assigning of signed numbers, so it is represented with the sign magnitude and sign complement system. So since we have 4 bits for code, so that's why you have to represent your signed for each decimal digit for you to determine the sign of the numbers. So we will start with binary. Since binary, so we will be representing the positive. So since positive man siya, diba? For arithmetic subtraction of complements, if you have your positive, so that will serve as 0. And if you have your negative, so you will have your 1 for binary numbers. So with this BCD decimal arithmetic, you will be using +0 for positive. So +0 ang mga positive. While for negative, you will be using instead of minus, you will be using the +9. So again, that will serve as your negative. So the sign complement system for decimal is 9s and 10s. Most used is the 10s complement. So to produce your 2's complement, you have to apply your 10s complement. So again, don't forget, for this arithmetic, you will be using 0 plus 0 for plus sign, and +9 for negative sign. So we will have an example for you to understand this situation. So this one is an example for the addition of digits. So it includes the signed digit and the discarding the end carry. So all operation assumes that all negative numbers are in 10s complement. So again, if you have your negative number, you have to get first the 10s complement. So the 9 in the leftmost, so with this example, the +9 will serve as your minus, and the +0 will serve as your plus or negative. So with this example, you have your +375 plus -240. Diba, in addition, if you have your plus times minus, so it should be minus. So that's why sa ubos, you're using positive 9. That will serve as your minus. You will check ha. So again, if you have your negative numbers, you have to get the tens complement, and that tens complement will be added to your decimal value. So you have your positive 375, which will be written as plus 0,375, and you have your negative 274, which will be written as plus 9760. So how do you get your 760? So your 760 is the tens complement of your negative number. Since hagi ito pag complements, ang saon pag complements. So your complements, tens complement. So it will be your r minus n, rn minus 1 minus n plus 1. So the tens complement of your 240 will be 9760. So that's the 9 will be the excess number, or the end carry of your tens complement of your negative numbers. So again, if you're going to check the tens complement of 240, so that will serve as 9760. Since you have already get the tens complement, you have to add your tens complement with the original number of your first. So you have your 5 plus 0 is 5, 7 plus 6 is 13, and 3 plus 7 is equals to 10 plus 1. So serve as your 1. And after that, minus na siya. Plus 9 will serve as your minus. So the total for your sum is positive 135, or the plus 135. Question is, why is it that you're using plus 0 instead of negative or the plus 9? So since your 375 is just bigger than your negative 240, so the result would be positive. So again, for this one, the two numbers are added and the end carry is discarded to obtain the positive 139. Next example. For the next example, you will be using the negative, minus, and the positive 240. So in this example, as you can see, if you're going to multiply the negative and the negative 240, so that will serve as your alibay lang. So again, the representation of your positive is plus 0, and since positive man siya, you have your positive 375. Positive 375, that's why my representation is plus 0,375. If you're going to multiply the negative and negative, the result will be positive. Mauna siya, positive 240 plus positive 615. So how do you get that solution? Yan sa pagkuha ang solution. So, negative times negative is equals to positive. So your result will be 615. So there will be no more complements because your sign is all positive. Next example, you have your 215 plus minus 302 is just equal to negative 87. So again, if you have your negative sign, you have to get the tens complement. Tens complement, ha? So if you're going to add this one, your 999 minus 9 will serve as your 87. So again, your positive will be presented with plus 0, 215. Your negative will be presented with plus 9. But if you're going to get the tens complement of 312, the result will be 312. The result will be 9698. Then you have to add. The result will be 9913. Question is your negative 87 equivalent to negative 913 or positive 913? Kuha siya, di ba? Again, you have to discard your carry, and then the result will be negative 913. So that is for the decimal arithmetic for BCD numbers with signed numbers. Signed numbers, especially those negative numbers. So another decimal codes is the weighted codes or the unweighted code. So for your weighted codes, it is categorized into BCD 2421, 24, negative 2, negative 1. And for unweighted code, you have your excess 3. Excess 3 na siya. So we will start with BCD 8421. So this is an example of weighted code. The 8421 and 2421. So in weighted code, each bit position is assigned a weighing factor. So each digit can be evaluated by adding the weights of all the ones encoded decimal combination. So again, for your BCD code, has a weight of 8421. So naa siya weight nga 8421. So if you have a bit assignment of 0110, so this is interpreted by the weights to represent the decimal 6. Ayan siya. So you have your 8. Ang weight nimo is 8, 4, 2, 1. Yeah, this should be interpreted with the representation of your of your 8, 4, 2, 1 weight. So your 8 is multiplied by 0. Ano siya, diba? You have your weight 8, 4, 2, 1. It will be multiplied by 0 plus your 4, kani siya, will be multiplied by 1. Kani siya. Diba? You have your 0, 1, 1, 0, 1. So this will serve as your 8, your 4, 2, and 1. So again, your 8 is 0. Multiplied by 0. Your 4 is multiplied by 1. and your 2 is multiplied by 1. Yeah, and then your 1 is multiplied by 0. So if we're going to calculate the value of this one, that will serve as your decimal 6. Ikani, may mo naman yung 0. Ikani sa may mo 0. So 4 plus 2 is just equal to 6. So this is for weighted code using 8421. Another example. So this is the representation of the weight of the BCD code that has a weight of 2421. So the bit assignment is 1101. So your 1101 will be interpreted as decimal 7. So we will check ano na 7 siya. So again, your 2 is times with 1, plus 4. Your weight 4 is times with 1, diba? Multiplied by 1. Again, your weight 2 is multiplied by 1. Your weight 4 is multiplied by 1. And then your weight 2 is multiplied by 0. Then, your weight 1 is multiplied by 1. So if you're going to get the result for this one, this will serve as 7. So you have to note that some digits can be coded in 2 possible ways in 2421. So there are possible ways in 2421. Example, you have your decimal 4 that can be coded with 0, 0, 1, 0, 1, 0, 1. Why? Baka ni, but you have your 2, 4, 2, 1. If you're going to get the decimal value for 4, kanira siya naka-on. Can be, kani siya naka-on, but the rest is off. Kaya nahog naman ni siyang 4. Diba? We're looking for decimal 4 man. So, kani siya, pwede siyang on. So, that will serve as your 0, 1, 0, 0. What else? If you will not use the 4, weight 4, you can use the weight 2. Diba? Weight 2. Example, 2, 4, 2, 1. So, dili ko na siya gamiton. Kaya ginamit ko na siya ganiha. So, i-off ta na siya. So, you can use the 2 and the 2 and the rest is 0. So, if you're going to add that one, so mahawag siya 4. Decimal 4. You have your 2 and 2 that will serve as your decimal 4. So, that is the use of weighted codes. The next for weighted codes is your unweighted. So from weighted, you will have your unweighted code. So dili siya weighted. So there will be no 8421 and 2421. So this is an example of self-complementing codes. So this code have the property that 9's complement of decimal numbers is obtained by changing 1's to 0's and 0's to 1's. So with this code, you will have to add your decimal number with exist 3 code. So ang imong i-add is 3 code. So if you have your 395, so it will be added with 3. So mahog na siya 695. 698. 6. 3 plus 3, 6. 9 plus 3, 12. 6, 12, 8. So if you're going to get the code for that one, so you have your 6. This will serve as your 12 and your 8. So, ana ra siya pag-represent sa exist 3. you have to add 3. Example, you have your 604. So, using excess 3. So, for this one, mauna siyang 937. So, if you're going to check, this will serve as your 9, 3, and this will serve as your 7. So, that is your excess 3. So, it can be obtained by the or by adding plus 3 or by adding the value 3 to its corresponding binary value. So, mag-add ra kag 3 for excess 3. Next code is your 84, -2, -1. So, this is an example of assigning both a positive and negative weights to a decimal code. So, kani you will be using the positive or negative weights to decimal code. So, for this example, if you have your 0110, so that will serve as your 6, diba? So, how to get 6 using the way code 84, -1, -2. So, dili siya pwede ang 8. 0 na siya. Plus 4. Can be 4. So, kani siya will serve as your -2 times 1, -2. And or -1 times 0, 0. So, the result will be 2. A decimal 5 by 84, -2, -1. So, mahog siya 8 plus 0 man siya. So, naka-on man ang 8. So, naka-8 naka-on sa the -2. So, i-minus ni mo 2. So, napakay 6. You will have to get the 5 man. So, kuwangan pa ni. So, kinana naka-on ang -5 to make 8 minus 5. So, your result will be 5. Ayan siya. For the 84, -2, -1. So, these are the list of your decimal codes. You have your decimal digit represented by BCD. Saan siya pag-represent sa 0. And then your 2421 and excess 3 and 84, -2, -1. So, again, for excess 3, you have to add the number of 3. The number by 3. 3. So, good ta. So, example, I will get the value for your example number 5. So, if you're going to get the BCD, ang mag-on ragid ani niya for 5 is this 4 and 2. So, the rest is 4 and 1. So, the rest is 0. So, 0 siya, 1, 0, 1. So, check siya. Another 5. To get 5, you can on the 1, 0, 1, 1. So, 5 sa siya. Or you can on 0, 1, 4, and 1. So, 5 sa siya. So, this will represent 2 binary digits for 5. Another example. How about if you're going to get the excess 3 for 5? Na excess 3. So, it will be 5 added by 3, mahog siya 8. So, the representation will be 1, 0, 0, 0. O how about for 84, -2, -1? So, ang on niya is 1, 0, 1, 1. No, kay your 8 will be deducted by 2, serve as -6. Minus 1, this will serve as 5. So these are the representation of your decimal digit 2, BCD 8421, 2421, excess 3, and 84, -2, -1. So again, from 10 to 15, this will serve as your unused bits or your invalid bits. Hindi na siya pwede. Invalid bit combination. See, that's all for our discussion for the binary code. So these are I'm only discussing the weighted code and unweighted code, the BCD code with the BCD addition and the decimal arithmetic, and the excess code katong na unweighted code.